Imagine a construction site where no scaffolding blocks the skyline, no steel workers dangle from beams, and no heavy machinery shakes the ground. Instead, shimmering fleets of holographic drones weave structures into existence, assembling light, matter, and energy with precision beyond human hands. This is the world of holographic construction drones, autonomous builders that blend hard engineering with photonic projection, reshaping how humanity creates its cities, colonies, and habitats across worlds. The story of these drones begins with the merging of two powerful frontiers, holography and nanofabrication. Traditional holograms project light patterns into 3D space, creating the illusion of form. But when holography advances into the realm of matter control, through photonic confinement and quantum coherence, it stops being an illusion. The hologram becomes tangible. Each drone acts as both architect and craftsman, projecting structured light fields that trap, position, and fuse microscopic building particles in midair. Imagine a drone hovering over a construction zone, its emitters painting invisible frameworks of light, then solidifying those frameworks atom by atom until steel-hard lattice emerges from thin air. These holographic drones rely on a new branch of physics called solid light engineering. In this system, lasers and metamaterial projectors generate energy fields that shape matter using photonic pressure. The drones don't carry bricks or beams, they carry photons structured in quantum phase arrays. When enough energy intersects at precise focal points, molecules of carbon, silicon, or composite dust align and bond under controlled resonance. This allows entire walls or bridges to be drawn in open space, skipping the old logistics of shipping heavy materials. The building materials can come from local air, ground minerals, or vaporized elements processed on site. What makes holographic construction drones revolutionary isn't just speed, it's adaptability. A swarm can construct a skyscraper's frame in a fraction of the time it would take human crews. But it can also redesign on the fly. If an architect updates a blueprint in real time, the drones instantly adjust, reconfiguring the structure as holographic schematics shift in their field of view. Each drone carries its own AI microprocessor capable of analyzing stress points, material fatigue, and energy balance, while communicating with hundreds of others through quantum-linked networks. Together, they operate like a hive mind, one organism, thousands of hands. The core intelligence behind these drones stems from neural quantum hybrid AI systems, capable of translating architectural intent into physical execution. A designer no longer needs to issue explicit mechanical commands. Instead, the AI interprets blueprints, environmental conditions, and aesthetic goals simultaneously. For example, if high winds threaten stability, the drones might reinforce load-bearing columns with denser crystalline structures or reroute thermal lines to prevent material warping. The result is construction that evolves dynamically, living architecture that adapts to weather, energy flow, and human presence. But perhaps the most breathtaking aspect of holographic construction drones lies in their holographic overlay capabilities. Before a single atom is laid, the drones can project a life-sized simulation of the finished structure, complete with lighting, shadows, and even holographic people walking through it. This allows architects, investors, and city planners to walk through virtual buildings on the real site, adjusting dimensions, aesthetics, and layout in real time. It turns design into a tactile experience, merging augmented reality with physical space in a way that traditional 3D modeling never could. From a technological standpoint, these drones rely on breakthroughs in photonic crystals, anti-gravity stabilization, and quantum coherent computing. Their projectors can manipulate electromagnetic fields at resolutions smaller than a nanometer, allowing for material precision rivaling atomic printers. Each drone also carries a miniaturized gravitic stabilizer that keeps it suspended with perfect balance, even in high winds or zero-gravity environments. This enables their use not only on Earth, but on lunar or Martian colonies, where the scarcity of atmosphere makes traditional construction nearly impossible. In those hostile environments, holographic drones could literally build habitats from the dust itself, binding regolith particles into sealed domes capable of sustaining life. In the near future, entire construction companies may be replaced by fleets of these autonomous builders. Imagine the skyline of a futuristic city, glowing at night as holographic drones dance in orchestrated patterns, assembling towers from streams of light. Each construction site becomes a ballet of precision photonics, with drones weaving luminous strands across the air like digital fireflies. Within hours, those strands coalesce into tangible frameworks, bridges, skyscrapers, domes, and floating platforms. The economic implications are immense. Costs drop drastically as transportation and labor are minimized. Safety risks plummet since humans no longer need to operate in dangerous heights or unstable zones. Even environmental impact is reduced. The drones use locally sourced material and produce almost no waste. One of the most visionary applications is in rapid disaster recovery. After an earthquake, flood, or war, holographic drones could rebuild shelters, hospitals, and infrastructure in days instead of months. Their ability to scan the terrain, assess structural damage, and generate custom-fit replacements in real time means that reconstruction becomes an automated process. Humanitarian teams could carry compact drone swarms that, when deployed, map the landscape and start printing bridges or shelters from available debris, transforming chaos into order. On a planetary scale, these drones may even redefine space colonization. Instead of sending pre-built modules to Mars, we could send swarms of holographic drones with the raw blueprints of a city. They'd extract resources directly from the Martian soil, using solar energy and atmospheric carbon to produce building material. Within weeks, entire habitats could rise, air-sealed, radiation-shielded, and self-sustaining. In orbit, the same drones could construct massive ring stations or solar collectors, assembling kilometer-long structures that would be impossible for human hands. However, such power raises new ethical and economic questions. If drones can construct anything, anywhere, who controls their use? Could a rogue swarm erect unauthorized fortresses or clone critical infrastructure? Could governments or corporations monopolize their production, limiting who gets to build and who doesn't? The democratization of construction could lead to both empowerment and chaos, a world where anyone with access to AI schematics could reshape their environment. Regulation, therefore, would become essential. Licensing systems, AI ethics boards, and holographic building passports might be required to ensure responsible use. Even the aesthetic of architecture will evolve. Traditional buildings are designed within the limits of gravity, material strength, and human reach. Holographic drones erase those limits. Architects could create impossible geometries, floating structures, shifting facades, or organic towers that pulse with internal light. Buildings might not remain static objects but living systems, adapting, reshaping, or even migrating to new locations. In such a world, architecture becomes a form of dynamic art, responsive to emotion, season, or event. A concert hall could reconfigure its acoustics mid-performance. A hospital could shift its layout based on patient flow. Entire neighborhoods could bloom from the ground like time-lapse flowers, guided by environmental data. At the heart of this revolution lies the human desire to build, to transform imagination into reality. Holographic construction drones represent the purest realization of that impulse. No longer confined by tools, materials, or physics as we know them, we gain the ability to manifest our visions directly. The cities of the future might be luminous, alive, and endlessly changing, sculpted by fleets of intelligent light. Picture standing in a megacity of 2,150. The skyline breathes, glowing softly as drones dart between towers, maintaining, expanding, and reshaping them. Below, streets and bridges realign as traffic patterns shift. The world itself becomes an intelligent organism, with holographic drones as its cells, healing, growing, evolving. The sound of hammers and engines is replaced by the quiet hum of photonic resonance. Construction becomes creation, pure and immediate. The rise of holographic construction drones won't just change how we build, it will redefine what building even means. The line between architecture, art, and life will blur. Humanity will finally step into an era where our greatest structures are born not from brute force, but from the precision of light, the elegance of intelligence, and the boundless potential of imagination. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.